In this video, we will explain how a helicopter flies through the flight made by the JAES CEO, who will leave the city of Treviso to reach his field offices in Sicily. After getting on board, the JAES helicopter lifts from the ground and flies towards its destination. As it leaves the city of Treviso, it flies over the sports arena of Treviso Basketball Team, which recently achieved the promotion to the Serie A, the top professional division of the Italian basketball championship. This important accomplishment was made possible thanks to the staff, the consortium members, the players, especially our team captain, Matteo Imbrò, and thanks to the extraordinary fan club of Treviso Basketball Team. During this flight, we will see what are the main components and controls that allow the helicopters to do the things airplanes cannot. We will also see the landing of the JAES helicopter near the Mondello Beach. The Mondello Beach is considered among the most beautiful and charming beaches of Sicily. The CEO of JAES was born in Palermo, so he's very attracted to this place, and he's very happy to make his comeback here. Helicopters are aircraft able to stay still in the air and to move straight upwards or downwards. Their ability to move freely in the air is guaranteed by large propellers turning on vertical axes through power supplied by an engine. It is believed that Leonardo da Vinci's sketches from the late 15th century were the predecessor to the modern-day helicopter. But it was only during the 40s of the 20th century that the world's first practical helicopters made their appearance. This helicopter has a turbine engine called turboshaft engine. This type of engine is not used to produce thrust, but to power a mechanical shaft. It is in fact equipped with a compressor, a combustion chamber, and a series of turbine stages inside the gas generator. The purpose of the compressor is to suck the air in and pressurize it. The fuel burns immersed in this hot and pressurized air. The exhaust gas produced by this combustion leaves the combustion chamber, passing through the turbines and makes them turn. There are two sets of turbines. These turbines turn the compressor, while these turbines turn the rotor shaft. The number of blades of the main rotor can vary according to the size and weight of the helicopter. What is certain is that a helicopter can have a minimum of 2 up to a maximum of 7 blades. As in the case of the Sikorsky S-65, one of the largest, heaviest transport helicopters in the Western world. A rotor with many blades requires a larger and powerful engine. Greater size means higher costs. Like in the case of wind turbines, a helicopter with many blades will be more powerful but less efficient than one with less blades. The blades of the helicopter, by rotating in a certain direction, generate an equal force with opposite direction, according to Newton's third law of motion. For every action, in fact, there is an equal and opposite reaction. So, if an object exerts a force on another object, then that other object is going to exert an opposite and equal force on the first object. This means that during their rotation, the blades that are imparting a force to the air in this direction, they consequently receive an opposing force from the air. This is known as torque reaction, which is opposed to the rotation of the blades. So if the blades start rotating in this direction, the entire body and fuselage of the helicopter would spin in the opposite direction. For this reason, every helicopter has a tail rotor that allows to counteract this torque reaction. The tail rotor is composed of a single propeller, placed precisely on the tail of the helicopter. By rotating, this propeller pushes the air in the opposite direction and produces thrust, which is opposing the direction of the torque reaction in order to stabilize the entire helicopter. By changing the pitch and consequentially the angle of attack of its blades, this propeller is able to increase or decrease the airflow passing through the blades, and therefore increase or decrease thrust opposing the torque reaction. We already talked about the angle of attack in our previous video about airplanes, in which we explained that this angle was formed between the chord line of the wing of the plane and the airflow direction. During the takeoff phase, the tail force tilted the plane, increasing the angle of attack, and consequentially the thrust towards the wing. This caused the whole aircraft to lift up. The helicopter rotor blades have a very similar airfoil technology compared to the airplane wings and follow the same principle. In a stable condition, the thrust generated by the tail rotor is able to perfectly balance the torque reaction of the main rotor, allowing the helicopter to stay still in the air with the nose facing in this direction. As we know, in addition to taking off and landing vertically, the helicopter is able to perform many other maneuvers. It can move forward and backward, and in general it can move in any direction in a 360-degree space. When it changes its direction, it could also increase or decrease in altitude. It is also able to achieve a clockwise or a counterclockwise yaw rotation. How does it do that? If we look closely at the main rotor of this helicopter, we will notice that it is composed of several elements, like the shaft and the swash plate mechanism. The swash plate mechanism consists of a bottom swash plate, a bearing, and a top swash plate, which is attached to the rotor shaft. The bottom swash plate is able to perform these movements. A bearing placed between the bottom and the top swash plate ensures that the latter is able to follow all the motion of the bottom swash plate, while at the same time it can rotate along with the rotor shaft. As the collective pitch control is raised by the pilot, which is the lever usually located on the left side of his seat, there is a simultaneous and equal increase in pitch angle of all main rotor blades. As it is lowered, there is a simultaneous and equal decrease in pitch angle. The cyclic control is used to control the main rotor in order to change the helicopter's direction of movement. It is usually projected upward from the cockpit floor, between the pilot's legs or between the two pilot seats in some models. This is perhaps the most sophisticated and delicate control of the entire helicopter, since it changes the mechanical pitch angle of each main rotor blade independently, depending on its position in the cycle. The pitch is changed so that each blade will have the same angle of attack as it passes the same point in the cycle, changing the lift generated by the blade at that point and causing each blade to fly up or down in sequence as it passes the same point. When the pilot moves the cyclic forward, the control rods will tilt the blades in this way, increasing the angle of attack only of the blades on the left side of the cycle. By doing this, the lift will be greater on the rear side of the cycle, causing the helicopter to move forward. It seems like a paradox. Actually, this happens because of gyroscopic precession. This is a phenomenon occurring in rotating bodies in which an applied force is manifested 90 degrees later in the direction of rotation from where the force was applied. As we've already seen, to counteract the torque reaction, helicopters are equipped with the tail rotor. The anti-torque pedals, located on the cabin floor by the pilot's feet, control the pitch and therefore the thrust of the tail rotor blades. This, consequentially, allows the pilot to control the direction that the nose of the aircraft points. From that neutral position, applying the right pedal causes the nose of the helicopter to yaw right, and the tail to swing to the left. Pressing on the left pedal has the opposite effect. The nose of the helicopter yaws to the left and the tail swings right. During the flight, the helicopter pilot knows very well that for every action, there's a different reaction. So, for instance, moving the cyclic to the right, the helicopter will tilt to the right, but at the same time, it will lose altitude. So, it will be necessary to control the collective and consequentially the anti-torque pedal to keep the helicopter at the desired height. After this long journey, the CEO of JAES finally arrives at his destination. Now the helicopter pilot makes the necessary maneuvers to land on the landing platform, placed just a few steps from the beautiful Mondello Beach. 10 years in the industrial supplies sector have led JAES to become a qualified partner for some of the most important helicopter manufacturers. providing its technical support over a wide range of industrial components necessary during the production process of these incredible aircraft. We want to thank Domenico Bonula, a professional crew chief who supported us during the creation of this video. Finally, if you found this video useful, let us know by leaving a comment and subscribing to our YouTube channel to stay tuned on the latest release of new videos. Thanks for watching.